Hello people, my name is Asher and this is an instructional video for how to solve problem number 2.52. Now, before we begin, let's read through the question for part A. A hotel elevator ascends 200 meters with maximum speed of 5 meters per second. Its acceleration and deceleration both have a magnitude of 1.0 meters per second squared. How far does the elevator move while accelerating to full speed from rest? Now, before we try to solve this, let's draw a picture representing the scenario. Alright, now as you can see, my picture is an absolute masterpiece just for your viewing pleasure. Okay, so now that that's done, let's write down the values we know in our OFART chart. Alright, let's start with V initial, our initial velocity, and as seen in the question, the elevator starts from rest, meaning that our initial velocity is going to be 0 meters per second, remember those units. Now, we know we want to find how far the elevator has traveled when it reaches full speed, and we know that the maximum speed the elevator reaches is 5 meters per second, so we will write down that value for our final velocity, so V final equals 5 meters per second. Okay. We are also given the information that our acceleration is 1 meters per second squared, so let's write that down. A equals 1 meters per second squared. For the initial position and final position, we know that the elevator ascends 200 meters in total, so I'll label that on our picture right there, 200 meters. So in this case, I'm going to call where the elevator is right now at the bottom of the elevator shaft, y equals 0 meters. And I'm labeling this y, not x, just because y is generally height in graphs, so that's what makes sense to me right now. So this is going to be, not meter, 0 meters, right there. And therefore we can label y initial as 0 meters. There we go. So while 200 meters is where the elevator will eventually end up, part A just asks us for how far the elevator moves while accelerating from rest to full speed. So y final will be right about, we'll call y final like right here. Y final. And it represents where the elevator first reaches its full speed at. So right here, it starts going 5 meters per second at a constant rate. And because we're trying to find this value, I'm going to put a question mark right here. So y final equals blank meters right now. That's what we're trying to solve for. We also don't know how long it's going to take for the elevator to reach top speed. So right now I'm going to put time equals question mark seconds. So we don't know that. That's another unknown variable. Okay, so let's take a look at the 3 equations that are hopefully superimposed on the screen right there, if I've done my editing job correctly. As you can see, the first 2 equations use the variables y, f, and t, neither of which we know, meaning that we would have to solve for 2 different variables, which wouldn't be very easy. The last equation, however, uses yf, but doesn't need a t value, which means it will be much easier to use to solve for yf. Alright, so using that last equation there, let's put in our known values. So we've got 5 squared equals 0 squared plus 2 times 1 times x final minus 0. Alright, there we go. I'm running a bit out of space there. Okay, so we're going to get rid of all of those zeros because we don't need them, and 5 squared is 25, so 25 is equal to 2 times 1 times x final, which of course is equal to 25 equals 2 times x final. So then to get the final value, you're going to divide both sides by 2, just like that, and you'll get 12.5 meters, remember those units again, equals x final. So, in other words, the elevator will reach its full speed at 12.5 meters up the elevator shaft, which we can label right here, so 12 12.5, that's where it's going to start. Right there, start going 5 meters per second. Alright, let's move on to part 2. Part 2 reads, how long does it take to make the complete trip from top to bottom? Alright, so to solve this problem, we have to understand that there are 3 stages to the elevator trip. Stage 1 consists of the elevator speeding up to its maximum speed, and that's what we were using before, from 0 meters to that 12.5 we just found. That's stage 1. Stage 2 consists of the elevator traveling at a constant speed of 5 meters per second. So that's from 12.5 meters to some unknown value right now. It'll be moving at a constant speed during that time. And stage 3 consists of the elevator slowing down to a stop. So that'll be the final stage right up here. And one key piece of information we have is that the acceleration of the elevator and the deceleration of the elevator both have a magnitude of 1.0 meters per second squared. This means that the number of seconds and the distance it takes for the elevator to go from a rest to full speed and vice versa will be exactly the same, which will help us out a lot here. Now, given this, the fact that we know it took 12.5 meters for the elevator to go from rest to full speed, we also know it will take 12.5 meters for the elevator to go from full speed to rest. So, kind of the opposite there. Therefore, we can mark out the points between stage 2 and stage 3 by subtracting 12.5 meters from 200 meters to get 187.5 meters. So that's going to be right here, we'll call it. 187.5 meters is right at that point right there. So just to recap, right here it's speeding up to its full speed at 12.5 meters. It's going its full speed of 5 meters per second. And then once it hits 187.5 meters, it will slow back down to 0 right here over the same acceleration as it sped up right here. So as you can see right there, I have put the previous OFART chart for the previous problem in the homework, and I added our 12.5 meter value up there so that we know that. That's our X final. So that's the OFART chart for stage 1 in this case. So now we have to find the OFART chart for stage 2 as well. So our initial velocity will be 5 meters per second, right? Because it's going at a constant speed of 5 meters per second all throughout here. So that means that our final velocity will also be 5 meters per second. Next, our acceleration is going to be 0 meters per second squared because it's not speeding up or slowing down. There's no acceleration going on there. It's a constant speed. Our initial position, I'm going to call that y initial. Y initial is equal to 12.5 meters right there. And the y final is going to be our 187.5 meters. So 5 meters. Alright, I'm running out of room there. I'll try and scoot this over a bit. There we go. So that does say meters right there. It's now cut off these things, but just so you know, it says meters. Always use units. Alright, and again, the time is what we're trying to solve for in this case. We're trying to solve for how long it takes for the elevator to get from here all the way up to there, so time is blank seconds. We don't know that. Alright, now we have that second group OFART chart right up there, and we would ordinarily need to make a third group OFART chart for this distance. However, because these two have the same exact acceleration and starting velocity and ending velocities, they actually have the same exact time. So whatever time we find for this value, we're going to double that and then add it to this one, because these two, the times are exactly the same. Alright, so we are going to be using that equation right up there. So let's plug in our known values for stage 1, okay? This is to find the time between when the elevator first starts moving and when it reaches its full speed. So we're going to have 12.5 is equal to 0 plus 0t plus 1/2 times 1t squared. There we go. I know that got cut off a bit, but that is a t squared right there. So let's get rid of those zeros now. So we have 12.5 is equal to 1/2 t squared right there. There we go. So that's a 12, not a 7. Okay, we divide both sides by 1/2, so by 1/2, there we go, and that will equal 25 equals t squared, and then square root both sides, square root that, now that's 5 equals t. Now, ordinarily, we would have another root right here, the -5 root. However, because we're dealing only in positive time right now, we don't need to count that root. So we're only using 5 seconds equals t right there. So between here and here, it takes 5 seconds for the elevator to reach full speed. So I'll write that down, 5 seconds for the elevator to get all the way up there. Alright, so now we're going to do the same thing with the other stage. So stage 2, where it's traveling at a constant speed, we're going to find how long it takes to get from here all the way up to here. So we're going to use the same exact equation, but different values, of course. So plug in those values from our stage 2 OFART chart, and it'll look like this, 187.5 is equal to 12.5, I'm writing small so I don't run out of room here, plus 5t plus, I'll write down here, 1/2 times 0 times t squared. Okay, so there's that. I know it's kind of weird because I had to use multiple lines, but there's that. And we're going to get rid of all of the zeros, so 187.5 equals 12.5 plus 5t. All of that is multiplied by 0, so that's gone. So we're going to subtract 12.5 from both sides to get 175 is equal to 5t. Okay, there we go. Now we'll divide both sides by 5 to get 35 seconds equals t right there. So between right here and right here, 35 seconds will pass. So 35 plus 5 will be 40 seconds. There we go. So at that point, it's going to have traveled 40 seconds in total. And then because stage 3 is exactly the same as stage 1, it'll last 5 seconds also. So we can add 5 more seconds on for stage 3 without even having to compute anything, which will be 45 seconds in total. Alright, so now we know that from the time when the elevator started moving all the way down here to the time when it stopped moving all the way up here spanned about 45 seconds right there. So 45 seconds is our answer. There we go.